A composting toilet is a dry toilet that uses a predominantly aerobic processing system that treats excreta, typically with no water or small volumes of flush water, via composting or managed aerobic decomposition. Composting toilets may be used as an alternative to flush toilets in situations where there is no suitable water supply or waste treatment facility available, or to capture nutrients in human excreta as humanure. They are in use in many of the roadside facilities and national parks in, for example, Sweden, USA, United Kingdom and Australia. The human excrement is normally mixed with sawdust, coconut coir or peat moss to support aerobic processing, absorb liquids, and to mitigate odor. The decomposition process is generally faster than the anaerobic decomposition used in wet sewage treatment systems such as septic tanks. Composting toilets are usually set up without urine diversion but can also include urine diversion. Offering a waterless urinal in addition to the composting toilet can help keep excess amounts of urine out of the composting chamber. Composting toilets should not be confused with urine-diverting dry toilets, which are also referred to by some people as Eckerson toilets. History. Before the flush toilet became universally accepted in the late 19th century, there were inventors, scientists, and public health officials who supported the use of dry earth closets, or composting toilets. These were invented by the English clergyman Henry Mole, who dedicated his life to improving public sanitation after witnessing the horrors of the cholera epidemics of 1849 and 1854. Impressed by the insalubrity of the houses, especially during the Great Stink in the summer of 1858, he invented what he called the dry earth system. In partnership with James Banu, he took out a patent for the process. Among his works bearing on the subject were, The Advantages of the Dry Earth System, 1868. The Impossibility Overcome, or the Inoffensive, Safe, and Economical Disposal of the Refuse of Towns and Villages, 1870. The Dry Earth System, 1871. Town Refuse, The Remedy for Local Taxation, 1872, and National Health and Wealth Promoted by the General Adoption of the Dry Earth System, 1873. His system was adopted in private houses, in rural districts, in military camps, in many hospitals, and extensively in the British Raj. Ultimately, however, it failed to gain the same public support and attention as the water closet, although the design remains today in some parts of the world. Operating process. Although there are many designs, the process factors at work are the same. Rapid aerobic composting will be thermophilic decomposition in which bacteria that thrive at high temperatures oxidize the waste into its components, some of which are consumed in the process, reducing volume, and eliminating potential pathogens. Drainage of excess liquid or leachate via a separate drain at the bottom of the composter is featured in some manufactured units, as the aerobic composting process requires moisture levels to be controlled, too dry, and the mass decomposes slowly or not at all. Too wet and anaerobic organisms thrive, creating undesirable odors. This separated liquid may be diverted to a black water system or collected for other uses. Some units include a urine separator or urine diverting system. Urine can contain up to 90% of the nitrogen, up to 50% of the phosphorus, and up to 70% of the potassium present in human excreta. In healthy individuals it is usually pathogen-free, although undiluted it may contain inorganic salts and organic compounds at levels toxic to plants. The other requirement critical for microbial action, as well as drying, is air. Commercial systems provide methods of ventilation that move air from the room, through the waste container, and out a vertical pipe, venting above the enclosure roof. This air movement will vent carbon dioxide and odors. Some units require manual methods for periodic aeration of the solid mass, such as rotating a drum inside the unit or working an aerator rake through the mass. Composting toilet brands have different provisions for emptying the finished product, and supply a range of capacities based on volume of use. Frequency of emptying will depend on the speed of the decomposition process and capacity, from a few months to years. With a properly sized and managed unit, a very small volume of a humus-like material results, which can be suitable as soil amendment for agriculture, depending on local public health regulations. Composting toilets greatly reduce the volume of excreta on site through psychrophilic, thermophilic or mesophilic composting and yield a soil amendment that can be used in horticultural or agricultural applications as local regulations allow. In combination with a constructed wetland, these even require only the half area. These should not be confused with the pit latrine, arbalou or tree bog, all of which are forms of less controlled decomposition, and may not protect groundwater from nutrient or pathogen contamination or provide optimal nutrient recycling. Types: manufactured composting toilet systems. Several manufactured composting toilet models are on the market, and construct-it-yourself systems are also popular. Self-contained composting toilets complete or begin the composting in a container within the receiving fixture. They are slightly larger than a flush toilet, but use roughly the same floor space. Some units use fans for aeration, and optionally, heating elements to maintain optimum temperatures to hasten the composting process and to evaporate urine and other moisture. Operators of composting toilets commonly add a small amount of absorbent carbon material after each use to create air pockets for better aerobic processing, to absorb liquid, and to create an odor barrier. This additive is sometimes referred to as bulking agent. Some owner-operators use microbial starter cultures to ensure composting bacteria are in the process, although this is not critical. Remote, central, or underfloor units collect excreta via a toilet stool, either waterless or microflush, from which it drains to a composter. Vacuum flush systems can flush horizontally or upward with a small amount of water to the composter. Microflush toilets use about 500 milliliters per use. These units feature a chamber below the toilet stool where composting takes place and are suitable for high volume and year-round applications as well as to serve multiple toilet stools. Desiccating toilets dry the excreta to destroy pathogens, though one study suggested that subsequent contact with moisture can cause rehydration of pathogens. Self-built unit. Site-built or self-built composting toilet designs vary, ranging from roll-away containers fitted with aerators to large concrete sloped bottom tanks. Regulation: there are no universally accepted performance standards for composting toilets in the United States, although 7 jurisdictions in North America rely on testing of manufactured systems to American National Standard NSF International Standard ANSI/NSF 41 to 1998. Non-liquid saturated treatment systems. An updated version of ANSI/NSF Standard 41 was published in 2011. Systems might also be listed with CSA, CETLUS, and other standards programs. Gallery. Notes. References. External links: Humanure Handbook Online, What is a composting toilet system and how does it compost? Converting to a composting toilet on a boat.